here to talk today about PG Lake. I am one of the hosts of PostGIS Day with Paul, and I love PostGIS Day so much. Thank you all for being here. To our amazing presenters, thank you so much for spending time sharing your story with us. So if you came today or found this video later online, I appreciate you being here. Happy PostGIS Day. So yeah, let's talk about PG Lake. So this is an open source Postgres extension that we just released through Snowflake, and it's really exciting. It's got some cool geospatial capabilities, so that's what I want to talk about today. Yeah, I'm online as SQL Liz. If you want to find me on social media, I do Postgres advocacy work here at Snowflake. I do a lot of Postgres stuff with the United States Postgres Association, and I have an online Postgres meetup if you want to come join us and chat about Postgres every month. We have never had a PostGIS speaker at Postgres Meetup for All, so if anyone wants to come and host a session with us, we would love that. So yeah, let's talk a little bit about kind of we'll get started with some basics of just what PG Lake is, and then I'll kind of get more into the geospatial story. So PG Lake is going to connect Postgres to the lakehouse, sort of object storage, flat files, things like CSV, JSON, Parquet, and then Iceberg as well. PG Lake is going to both read data from object storage into Postgres and let Postgres query it as if it is native Postgres table data. And then Postgres can also write data from the database into any of these formats that PG Lake is compatible with. We probably should talk a little bit about what a lakehouse is. So a data lake traditionally is kind of a central repository where a large organization probably puts data. It's probably not super formatted. It may not be cleaned up. It kind of might be more like, we'll put a bunch of data here and we're not sure what we're going to do with it all later, but there might be a story for some of it. Lots of folks use Amazon S3 as a data lake storage area because S3 storage is really cheap. And the file formats are pretty interchangeable. A data warehouse is kind of more of a structured, kind of functioning database where you might be housing lots of different data from different sources, but they're in some kind of cleaned up, some kind of cohesive format, probably schemas that make sense, and you probably have, data analysts using that data. Things like Snowflake would be a data warehouse. So a data lakehouse kind of combines these two ideas, right? It lets you use these interchangeable kind of data formats, but also with some of the properties of like a data warehouse. And one of the things that's really changed kind of the data lakehouse conversation is the Apache Iceberg project. Apache Iceberg is kind of a Uber Parquet where they've taken all these flat Parquet files and then they added metadata on top of them. And that makes Iceberg, very smart. It can do things like, go back in time, know what the schemas were at different points in time. And it's really great at keeping track of things kind of like a database would do. And so the lake house conversation, a lot of that has to do with Iceberg. And Iceberg is a really important piece of technology, both for, I think, people in the kind of the Snowflake world and people probably in the more Postgres, PostGIS world. I expect a lot of us will be working with Iceberg in the future. I have a short little video here of just the most basic PG Lake functions. So once you've got PG Lake going inside Postgres, you'll create a foreign table. You'll create that foreign table typically with some kind of URL access. You'll tell Postgres that that's the foreign table location, and then Postgres can just read that data. The cool thing is it can read that schema data, so it can know what's inside that flat file without setting any of it up. And then Postgres can query this foreign table like it would any other Postgres native table. And in the same way that we just did that with a Parquet file, we can do the same kind of thing with Iceberg, and we can actually create Iceberg tables from other locations. So we could create Iceberg tables from another remote location, and then we could query that Iceberg file just like we're querying any other Postgres data. The PG Lake project is available under the Snowflake Labs GitHub repo. It's under the Apache 2 license. We've already had quite a few contributions from the community, so if you're interested in the project or building stuff with it or building on top of it, it's under that Apache 2 license, which is really exciting. If this project sounds familiar to you, you may have heard about a project that we worked on prior to the Snowflake acquisition when many of us were at Crunchy Data, and we worked on a project called Crunchy Data Warehouse. That was a very similar idea. A lot of the engineering that went into PG Lake is also in the Data Warehouse project. And the Crunchy Data Warehouse is built on top of the managed Crunchy Bridge platform, but some very similar ideas. So what's happened with that project now that we've been acquired by Snowflake is Snowflake has open sourced the project, and then also the same kind of pieces and components to it will be what we will use to connect our new service, Snowflake Postgres, with the Snowflake warehouse. And so there's some pretty cool and exciting things happening with replication that will be, kind of happening between the Postgres world and the Snowflake world inside Snowflake using the PG Lake project. You also might be curious about why Snowflake is interested in open sourcing something that they wouldn't necessarily have to open source or wouldn't necessarily want to. And Snowflake has a huge kind of footprint right now in open source projects. They're doing a lot of work on the Iceberg project I was just talking about. They had a lot of investment in Iceberg version 3. They're actually doing stuff with things like Apache Spark. Snowflake is doing some engineering work with the Apache NiFi project that inside Snowflake is called the OpenFlow. And Snowflake is really, seeing how much open source projects can really help drive innovation, both just in terms of the data world and kind of the larger way that people are interacting with data and how fast the world is moving. And so, being a part of these open source projects gives Snowflake and the whole Snowflake team kind of ways to interact with a bigger developer community, and then it also sort of can help drive innovation inside Snowflake itself with the engineering projects that we have. So to get going with PG Lake, you'll have to build the project inside your Postgres. I saw somebody just a couple days ago added some Docker files, so if you want to build PG Lake and you're a Docker user, I think it's probably a lot easier to get going with that Docker file. But yeah, once you've got it going, it's actually a whole set of extensions. So when you create it, you'll do it as a cascade. The main extension, PG Lake, runs as that component, and then if you want to use the spatial components to it, you'll do that as a second extension install, and that will install a couple different extensions that work for the spatial use case. So the geodata that you query with PG Lake is going to look very similar to that short demo I showed you a bit ago, where you'll just create a foreign table. You'll tell it that you want it to use the PG Lake server, and then you'll give it some kind of URL location, and then Postgres in turn will be able to read inside that file. And you see in this example, I've got a couple different columns, and Postgres was able to read the fourth column as a geometry type column. So as long as the geometry data is in binary, Postgres automatically kind of picks that up and knows that that's a geometry column and then can work with it with all of the PostGIS features. So what's cool about this is that even though the data isn't in Postgres or in PostGIS, because it's a foreign table, all of the things that you can use with PostGIS, like all of the functions, all of the ST functions, kind of that whole world just works natively with these foreign tables. There's quite a few file formats supported, all of the GeoParquet stuff, the JSON, Shapefiles are supported. You can do stuff that's inside zip files or inside compressed files, which is really cool. And then anything that's GDAL compliant, as far as we've seen, works pretty well. So I want to point out a couple features here. You can get this data from URLs, which is super cool. You can get this data compressed, which is amazing. And you get this automatic schema reading. All three of these features come from the DuckDB project. And so PG Lake kind of inside of it is sort of a hybrid between Postgres and DuckDB. If you haven't seen DuckDB yet, it is like amazing. It's one of my favorite projects right now, just in data. No matter what you're doing with data, there's probably something PG Lake can help you with. It runs in memory. You can kind of basically talk to any file format with CSV, with SQL. So if you want to talk to a CSV file with SQL, or you want to look inside a huge zip file and you just want to look at a couple things, you can do that with SQL. And DuckDB is amazing. And it's kind of got a lot of these features that we've talked about that sort of make all of this remote file reading happen. So PG Lake, because it has kind of this hybrid use case and some of this other stuff built into it with the DuckDB components, has a couple other features that a native Postgres or PostGIS implementation won't have, right? And that's that it's going to be looking at data in a columnar querying format. So traditionally, Postgres or transactional data is more row by row. So when you query it, you're generally querying out, in rows at a time. Columnar data lets you grab entire chunks of data in what's called a vectorized query, and where you can bring data out in chunks, and it's quite a bit faster. For analytics use cases, for querying large files, or looking across dates, creating kind of those look back queries where you want to collapse a lot of data into, weeks or months. PG Lake is extremely fast if you compare it to a traditional Postgres use case. One of the things I'm so excited about for geospatial use cases and for the PostGIS world is just the ability to connect the Postgres world to Overture Maps with PG Lake. So because PG Lake can just talk directly to any file kind of over a network, Overture Maps keeps all of their files in S3. And so you can just create foreign tables and connect right to Overture Maps. If you're not super familiar with Overture Maps, it's a project that was started by Microsoft, Amazon. I think there's quite a few other contributing partners to the Overture Maps project. And they're what they're doing is putting a lot of OpenStreetMaps, plus they've got some other data in there, and then it's all kind of available in GeoParquet formats, and it's available kind of open in S3 for anyone to download. So, they're kind of doing the heavy lifting of hosting all the data and collecting it all, and then it's sort of on the end user to figure out how to pull it into their application. Overture Maps was at PostGIS Day, I think, last year. And they had a really nice talk, so it's on YouTube if you want to find that, just an introduction to Overture Maps. A cool thing about PG Lake with Overture Maps or with any of these large data sets is that PG Lake will work with wildcards. So if you have large sets of data and you don't want to make a foreign table for every single file, you can use wildcards and it'll make a single foreign table for a large set of files, which is really nice. So one thing that I was testing and that is pretty interesting is that you can actually connect all the Overture map stuff and the foreign tables to QGIS. Now, Overture Maps has just tons and tons of data. So on my local computer, this is going to be really, really slow. So you can use features like the data layering to sort of create separate layers and bounding boxes so that you can kind of efficiently query the Overture Maps data without kind of overwhelming everything. So that to get sort of bounding box stuff, you're going to do something like this where you're querying that foreign table, the Overture places, or if you want to use one of their other layers, and then you're making a bounding box so that you can kind of work with it efficiently. So yeah, I was just kind of talking about is that, to get Overture Maps to Postgres and PostGIS now, you don't have to do any data loading. You don't have to do, OGR to OGR. You can go straight from Overture Maps, through PostGIS and then out to whatever application or, maybe a mapping application that you have. Also, it's 100% open source, which is really cool. So you can kind of DIY and figure out how you want to put all these components together. So yeah, before we sign off today, I want to show you a little demo that I built that uses PG Lake and is kind of a sort of an idea of how someone might combine PG Lake with PostGIS. So I've got, a coffee shop business. I've got lots of local data in my PostGIS database. But I want to do some, planning, and I want to kind of look at, maybe new sites that I might want to have a coffee shop at. And I want to use, the data that Overture Maps has to find competitors and competitor locations. So I've built this little sample app in MapLibre, and I will pull that up right now. All right, so here's my little map application. I've got several of my actual locations, and those are the blue dots, and they all have their circles around them to sort of simulate their service area. And I built a little layer here so that if I click on one of these locations, it's gonna do a little analysis for me and kind of tell me information about the site. So it tells me things like, okay, how many people live here? This is some population estimate stuff that I added. And then it's gonna load some competitor information from Overture Maps just right onto the layer. So I'm just gonna pull up my zoom in here. And you see, so it added those red dots come from the Overture Maps layer. Those are all the competitor locations, and you can see how close those are to my my blue dots, my own locations. And let me show you here. Some of you might find it interesting to look at the SQL. So let me show you kind of what that looks like. So you see I've got this is kind of the combo query that's combining the PostGIS and the Overture Maps data. So I've got, it's getting my geometry, it's getting everything from my local stuff, then it's doing a join to my Overture places, my remote data. It's setting an SRID because it's not reading that from a remote location. So yeah, you can see that it's able to join both this PG Lake data that's coming from Overture Maps and my local data, which I think is a really cool use case. Yeah, so that's the little demo that I had prepared to kind of show how you might combine some of this information from PG Lake with your PostGIS information. And I think one of the great sort of stories that you can kind of get out of this is just the ability to have access to so much more data without having to actually load it in, actually put it in your database, and go through the process of cleaning it, and all of those things. You have such a bigger world available to your applications, and to the geography data you already have. And because we live in this great big beautiful world, the primary key is the earth that we live on. So you can connect to all this kind of different data, and the geography of it all connects everything. Yeah, so just a couple last minute notes sort of about PG Lake and sort of how I think it can be used. I think it's going to be great for accessing remote data, for kind of maybe exposing your own data to your organization's data lake or a lake house, and kind of moving data maybe from your existing projects into a lake house kind of scenario. For spatial, there's currently no spatial reference system built in, so there's a couple limitations, and it's probably not like a huge performance fix for dealing with spatial data or spatial analytics. It's a little bit of a better fit for non-spatial analytics, but for big time spatial analytics, there's probably better things out there at the moment. Yeah, thank you so much for joining me today to hear a little bit about PG Lake. I'm happy to stick around and answer any questions that I can. My contribution to the PG Lake project was doing quite a bit of the documentation. So I don't know everything about some of the underlying engineering components, but I can help get you an answer, or get you connected with the right person. Yeah, thanks so much.